turning on the recording. What we finished up with on Friday was we did an activity with a partner, and then we did section 2-1, and then I stopped a little bit early because it was 4th of July weekend. So we'll just do a little bit of a warm-up of 2.1 problems. So then, like, when I tell people you can watch the video for attendance credit for the class if you ever miss class, what I mean is watch the video. It'll never be the whole 3 hours, and then do the practice problems as you're watching it and send me the practice problems, and then answer the secret question. That's how I know for sure that you really watched it and didn't just turn it on and turn it off or something like that, you know. So let's do a little bit of warm up from 2-1. My favorite part is checking, putting in values into expressions. So it's also the trickiest part. So let's evaluate expressions. And remember last time and 2 times ago, I said an expression that isn't an equation yet. It doesn't have an equal sign yet. Let's do x to the 3rd minus 8 for x equals 4. And then let's do x plus 5 over y. My dog. And let's throw in a negative here. Let's do x equals 2 and y equals -1. And there's one more that I like that has 3 variables. I'm going to put it on the next page, but I'll come back to this page. So the one that has 3 variables is, this is number 3, x squared minus 2y plus z for x equals 1, y equals 2, z equals 0. That's probably about as tricky as these ones get. I mean, you never know that, but when you do the assignment, it's not due till tomorrow. Chapter 2, assignment A, I think. It's a pretty short assignment, but you'll see a little variety of these kind of problems. Then we'll do like we'll rewrite 1 exponential or 2 expression, and then review which are the. I'll talk about this while you're thinking about these. Remember, I'm just reviewing. That's the variable. These are variables. That's the exponent. These numbers that aren't stuck with a variable are called constants. This number right here is called a coefficient. And then we say, this is a term, this is a term, and this is a term. So if someone asks you, what are the terms of that? I think that's a little bit of a waste of time, but it's just getting used to the language. X squared, -2y, and z. Those would be what the terms are. That number, I'll write it again, is a coefficient. So we talked about that too. There's another exponent. That's not super important to me because we'll practice a lot of that as we're going along the rest of the summer term. Get all this riffraff out of here. So I'll leave it on this page for a few minutes so you can figure those out and send me the answers if you want to, or on paper and send me a picture. Or if you're here in class, you don't even have to send me anything about it. You can just sit back and watch sometimes. Sometimes we might not feel good, or might have a sick kid, or internet issues. So 1, 2, and 3. Plus 3 again, x squared minus 2y plus z. Sometimes with these, we end up with fractions and things. We just leave them in fraction form if that happens. I'm going to throw down the exponent practice ones here too, so it's all covered and we can keep going. Rewrite in exponential form. There we go. So that's it. Enough of a refresher from Friday, I think. And then we'll go into the next. Mostly we're solving equations today. We're going to work with the foundations of solving equations while we solve equations, because most people in this class have already done equation solving, either in high school or in a math class, a college math class before this one. And so our textbook kind of in chapter 2, it kind of acts like you never have solved an equation before. And I just bet, actually send me in the chat, or do a hand raise if you want to, if you've solved equations before, algebra equations. You can either give me a thumbs up or thumbs down, or just tell me in the chat if you've solved equations before. And if you haven't, don't feel bad, because I'll walk you through it anyway. I could teach someone off the street who'd never done one in their life. I'm not bragging. I've just done it for a long time, so I could teach someone off the street, as well as same with calculus, actually, the calculus concepts anyway. I could just to throw in like a 7th grader and teach them that, but why rush it? Although some people, they want to rush. Okay, thank you for responding. I was going to do a poll last week and ask people which way they liked to be taught better. Remember, I was talking about, do you want the PowerPoint? Do you like clicking through the book, or do you like these whiteboard practice problems? But we only have 4 people here today right now, so I'm just going to wait and I'll do the survey tomorrow. Okay, so let's go through the answers. Who knows the answer to number 1? You can speak it up if you know.
56.
We'll just do it that way. If you know it. Yeah, good job, Eileen. All right. And let's look at the answer for number 2. Does anyone know that one? Weird looking a little bit, but I put the answer right here though. 4 to the 3rd minus 8 is 64 minus 8. So that's why it's 56. This one looks intimidating probably. I'm going to write it up here. Here's x plus 5 over y, which was -1. 7 divided by -1. That looks weird the way I wrote it here. -7. Anybody have questions about either of those, 1 or 2? Just wrote it up there because some people can't see the bottom of my screen. All right, let's take a minute or two to do these two in case you didn't have time yet. Oh, great. Now Valerie's here too. Hi, Valerie.
Hi.
We're just practicing a few problems before we go into the new material for today. So when we substitute in the values, we're very picky, we math teachers, to put each variable in the right place with parentheses around it. And we do that because, oops, I wanted it to be back to green. That means 2 times 2 plus z. We do that because if we're substituting in a fraction or negative, sometimes it gets confused if we don't put a parentheses around it. So I try to, on the last one, there's one where I failed to do that, like right here. I didn't put a parentheses around this or this because it didn't really matter, but I should just be consistent and always do it as the teacher too. You don't have to if you're getting the right answers. I'm not gonna check your work, as you know, only for the midterm. I'll look at your scratch paper, and tomorrow's quiz will be on a piece of paper, so I'll get to see your work. So just be careful. Be careful to do that and kind of take your time and be particular. Oh, I got some answers. It's gonna be 1 minus 4. So great. Good job. So we sometimes will have negative answers, sometimes we'll have fractions. That's okay. 1 squared minus 2 times 2 plus 0 equals -3 for this one. And then usually they'll ask you to go back in again with some different values for X, Y, and Z. Just to get us used to the fact that we can keep swapping them out. Unless it's going to make it undefined, we can keep doing that. And then in exponential form, kind of a similar idea. I take the thing that's getting repeated, and there's 3 of them. I put it in parentheses no matter what. And that's all they're asking, just to go that far. I know a lot of people want to go further. 5 to the 3rd is 125. So some people want to go ahead and write that, that's correct. But you don't have to. In this section, you can leave it like that. They're just trying to make sure that everyone has that concept. And then this one, the fraction, it's the same exact thing repeated 5 times. So I really, to save some space, I could just erase these out here and say that, well, it equals that to the 5th. And then you don't have to simplify it any further. Stop right there. Like I said before, you could go one step further, but it's not necessary. And it'll look uglier even. So we don't need to. I want to do one more exponential one like this, because I don't think I talked about one like this. What number am I up to? Let's see, 5. So this is 5. 2 times quantity A plus B times 2 times 2 times A plus B times 2 times A plus B. This is really rare. So same task, rewrite in exponential form. It's really rare, but I don't think I talked about one Friday. It looks weird. So sometimes people will just skip it because it looks so weird. But this helps me talk about, this is multiplication. In multiplication, you can change the order of what's going on. So I'm going to move all those free agent 2's to be together. So I moved them. That's the commutative property that says in adding and multiplying, you can move your terms around. Move terms around, and it doesn't change the answer. Wherever you want to put them, you can move them. Just, you can't toss them, but you move them. And then we could do the same with the A plus B's. Another thing too, just in case anyone doesn't know, it means the same if you have A plus B with the parentheses just stuck together like that. That means the same as if there's the dot between them. It's not the same as a plus though. That would be different. But it's the same as the multiplying. Let me erase that because that's going to look like that was the answer. There. And now, once they're reorganized like that, then we use associative property is for grouping. You could group them however you want in adding and multiplying. And so you might have just done that already in your head mentally without thinking, oh, I'm using the associative property now. Because then these got grouped. There's 3 of them. There's 4 of these. There's 3 of them. So it's 2 to the 4th times A plus B to the 3rd. Or you could put the dot in there. Or you could find what 2 to the 4th equals. Who knows? Who remembers what's 2 to the 4th after a busy weekend? Well, anyway, nobody's answering me, but I'm not.
Would it be 16?
Yeah, good job. Who was that?
That was me, Deanna.
Okay, thanks, Deanna. And then someone chatted it to me too. Thank you. Wonderful, Hannah. Great. So we could rewrite it as, oh, my video's on again. I can't seem to keep it off after all this training to keep them on at my meetings. We could write it as this. That would not be wrong. But if they are asking you just rewrite in exponential form, this right here is exponential form. It still has the exponents in both parts. So that's all the farther that you really have to go with that one. Okie dokes. Any questions, anybody? All right, then this is the thing that I said I was going to do. That was section 2.1. Instead of just going, I was saying this earlier, 2.2, 2.3, 2.4 in order, 3.1. But that would be, I think, boring for most of you. And I'm just going to ball them up and combine them all up into 3.1. So you'll see what I mean. This one is combining like terms. This one is removing symbols of grouping. And oh no, this one is story problems. And then this one is checking solutions, removing symbols of grouping. All those things we're just going to do as part of the equation solving. So I'm just going to move right along because chapter 3 is the real meat and potatoes, or carrot and fish, or whatever you want to, tofu and mushrooms of the course, chapter 3. So really want to focus as much of our time on chapter 3 as we can, and not waste your time either, but we'll still go through some topics from chapter 2. You'll see what I mean. But in chapter 3, they begin with very simple equations like this. Solve x minus 7 equals 0. I kid you not, it starts with that. 3x plus 6 equals 0. That's a two-step equation, and I'll explain those, of course. And let's say it's not always x either. Let's switch up the variables right away. And then how about 4v over 5 equals 20. So those are this for most people is harder, for sure. That's for sure harder for most people, and don't feel bad if it is hard for you. We'll practice plenty today. It's a lot of practice, just practice problems, practice making sure it makes sense. And then the topics from chapter 2, like I said, like combining like terms, removing parentheses, checking our solutions, and dealing with word problems. And I'll always talk about the properties. So like, as I go along, here's an example. To get x alone, let's say you've never solved an equation before. You could always send me the answers too if you want to, but I can't assume that everyone knows. I think everybody knows, but it might have been a while. But to get x by itself, we use the additive inverse. That was one of our words from last week, the opposite of -7. And we add 7 to both sides, so we have to keep it balanced always. We do the same thing on both sides just once, so we don't do it several times. We just do it once to each side, and that is the additive inverse. And I'll never ask you to explain the reason, but I'll just say them so you get used to hearing them. If you take the additive or inverse, this will zero out. That's what we want. When it zeroes out, that zero is called the identity for addition. And it's gonna have no effect on your x. If you're adding 0 to x, it's gonna stay x. I know most of you already know that that would have been x equals 7. And then we check our solution by substitute it back in for the variable and make sure that it equals what it's supposed to equal. So that's the check. So the check would be 7 minus 7 equals 0. Smile. Happy day. Okay. So that's the most simple as they get. Then this one, when we'll practice more. I'm not just going to plow through these. Number 2 is a 2-step problem. So we're going to have to get A alone and do 2 things first. So it's not just going to be a single step like number 1 was. I'm pausing in case anyone wants to send it. And then if you're thinking about number 3, you can always say, I always encourage people to talk it through. Some people are real talkers, language-based people, just all over the world. There might be someone who likes to talk things out and talk about a problem and discuss a problem. And so the math teachers that make kids just sit silently in class for like classroom management, they usually do that, but it's not good for the kids who they might be ESL students. They might just be people who culturally are used to talking through stuff using their hands and actions. And some people are hands-on, there's all the different kinds of learning and problem solving. But I always encourage this to talk through anything like this, like talk to yourself. It's not a crazy thing. So that question is saying 4/5 of what number equals 20? That's basically what's going on in that situation. So in words, that's what that would be. 4/5, that's the coefficient of what number equals 20. So sometimes that helps make sense. Sometimes a picture would help make sense of that one, but I'm not going into the distraction mode yet. We'll try to stay focused. So for number 2, I'm going to erase 3 for a second, just put it on the next page. So I have room to work for 2. Good job, the people who answered, very nice. We want this alone. Let me highlight it. We want that A alone. We can't get the 3 off of it because we have to work our order of operations backwards. So we talked about order of operations last week. And to get it to undo a situation, then we go backwards. So add and subtract first, then multiply or divide, and then undo your exponents and your parentheses, and you'll usually be fine. So undo the order of operations. Because sometimes people, when they're a beginner at this, they don't know. They're like, should I subtract 3? Should I divide by? Like they'll just start guessing. But and I also say work from the outside in. So we want to get the 6 off of there first. We're going to zoom in on that variable, but not yet. So that'll zero out. This will be equal to -6. And 3a plus 0 equals -6. Now 3a means 3 times a. 3 times what number equals -6? So again, talk to yourself. Self-talk is really good in math. Don't let anybody tell you it isn't. So is counting on fingers. So using hands-on stuff, some people really need that connection all the way through. That's okay. So 3 times what number equals -6? So if you know that just by talking through it, that's fine. But the steps would be undo multiplication by the opposite, which is divide. So I write divide with the fraction. Oops, it's got to be the same on both sides. Oh, girl, there we go. I make a fraction bar that says divide both sides by what's with a. And that's that other word we talked about last week, the multiplicative. Inverse. I don't know if we really talked about it that much, but we saw it. And that's the number that you multiply by something to undo it. So that'll be 1. 3 divided by 3 equals 1. That's the identity in multiplication. Or multiplication. 0 was the identity for addition. So divide both sides by 3, and then you've got your answer. Watch your negative divided by a positive is a negative, etc. And then we can do the check. If you're using a whiteboard or a tablet as a whiteboard, it's really handy, I think. Well, you don't do that. Don't erase your problem, but there we go. If we just plug that right into the original problem to check it, 3 times -2 is -6 plus 6 equals 0. And it checks out pretty fast. You don't have to take up any more space. If you're using paper, on the quiz, I'll say, show the check. So you'll just put it off to the side in a little box, the check box like this. 3 times -2 plus 6 equals question mark 0. That's how we'd show the check on paper. -6 plus 6 equals 0, and then make a check. It's all good. As you get more advanced, whether you take the next algebra from me or someone else, most instructors aren't going to make you show the check all the time because it's kind of time consuming. So we usually just ask people to show the check in the beginning to make sure they know how, because it's a really handy tool. So if we know how to check our answers, we know how to make sure that we didn't get any wrong before we even turned it in. It's nice. So it's a nice handy thing. Any questions about that one? All right, I didn't forget our friend 4v over 5 equals 20. Now the multiplicative inverse is the easiest way to do this one. It's not the only way. Of what's with the variable, which is this, is the reciprocal. That word, reciprocal. So if we multiply both sides by that fraction. Good job, Eileen. Yep. Then see what happens. It happens right away. If you do it this way, it happens all in one step. That cancels to 1. That cancels to 1. We end up with v equals, clean this up. that cancels to 1 and 5. 5 times 5 is 25 over 1. So it's 25. That is usually the hardest one-step equation example that people come across in this class. Like that's, for most people, that's the hardest. So if it feels weird to you, that's okay. Some people, and this would not be wrong, some people will say, well, why can't I do this? Divide both sides by 4/5. You can. You get the same thing will happen. You'll end up multiplying both of them by 5 over 4. And it'll just take an extra step. But you can, if you learned it that way. See, this will cancel. And you multiply 20 by the reciprocal of the denominator. And you'd still get v equals 25. And we can check with a picture too. 4/5 of 25 equals 20. Here's a picture check. Let's make a 5 by 5 square. 1, 2, 3, 4. Just bear with me. I know some people are like, stop it with the pictures. But in my grad school class, our instructor is always pushing this. So this is 25 squares. If I took 4/5, that's 25 total squares or little rectangles. If I took 4/5 of that, that would be 1, 2, 3, 4 rows. That's 4/5 of that picture. And 4/5, if I counted those up, it would be 5, 5, 5, 5. It would equal 20. So 4/5 of 25 equals 20. They teach children this with fractions and stuff. Now they do. So some people might feel more strong about those kind of pictures. Some people are just like, next, just tell me the recipe and I'll do the problems, but don't mess with me with that, Jenny. So you're not required, but if the pictures speak to you, then use them, because that's fine. It's more than fine. It's good if you're helping children who are having to do it that way. All right, let's practice a few more and then take a break. I know we started late, but we'll still take a break like normal. Otherwise, I'll get off my game. So I'll just be quiet and pause the recording. Let you all practice. 1, 2, 3, 4 pretty one-step or two-step equations here. So let's do y over 2 equals, that's a y. It looks really strange. We better use a different letter. Z over 2 equals 30. So solve. And these are called linear equations. And they're equations now, not expressions, because they have an equal sign already embedded in there. 11y minus 44 equals 0. Let's do 6x plus 4 equals 0. And they start off like this with the equal zeros. Let's do another one that's a little more exciting. 7a plus 9 equals 58. There. So these are, that's a two-step, a one-step, a two-step, 1 and a two-step. These are pretty gentle ones. So after the break, we'll do some more stressful. No, I'm just kidding. We'll do some more challenging ones and a couple story problems and pick geometry problems before we stop for today. I'll just pause this for a couple minutes. These are the secret questions for if anyone watches the recording. So you all are here today. You don't have to answer them, but you still can. They're an extra credit point each. So actually this would be 3 because question 2 has 2 parts. But if somebody's watching the video, that would be proof that they got as far on the video, or they know it like fast forward and get to the secret question. And then they text me that. So now you know how the MO is, how it goes if you miss class and you watch the video and send me the answer, send me the practice problems, the secret question answers. And even if you're wrong, then I know at least you were trying. Like if someone's not a native Lakota speaker and maybe they're Navajo, or maybe they're Tlingit or Polish. I mean, who knows what somebody's native language is, right? So if they don't know the 6 in Lakota, they could put that in there in another language if they want to. They still get credit because sometimes we have people in these classes that are not from around here. So, or from around here but didn't speak the language, and that's okay. Everybody's gonna learn, but anyway, then I put 6/15 to lowest terms because today's day 6 out of 15 total. So that's what percent of the class you've gotten through already. So actually I have to do that really quick. I'm gonna do it on paper. And then I'll go through the answers from the previous page in just a sec. Okay, moving right along. So I'll go over the process for solving these ones. Then we'll take our 10-minute break, and then we'll probably have about 20 minutes more of the topics from chapter 3 and combining with the chapter 2 topics. Oh yeah, I could just call on people, huh? Let's do that. Valerie, what's the answer to number 1?
It would be 4.
Good job. Yep. Let's see. I'll call on, just write down my list. Dawn, what's the answer to number 2?
60.
Good. Yes, ma'am. I'm going to write down that you're all doing these. And who's next? Deanna, what's the answer to number 3?
Is it -2/3?
Good job. Yes. Yep. That's probably the trickiest one on this page, huh? Well, 2 is tricky for a lot of people too. How about, let's see, who else is it? Eileen, what's the answer to number 4, please? Are you there, Eileen? People probably always want to sing you the song. I wonder if every single one of you in this class has a song named after your name. I think so, huh? That's pretty cool. I have one after my name, Jenny. Anyway, I didn't hear an answer for number 4, so let me ask someone else. I got distracted. Hannah, what's the answer to 4? Are you there? Yes, good job. Thank you. Okay. All right, so the answers are 4. We write y equals x equals -2/3. That was the answer to 3. Z equals 60. A equals +7. There's our answers. Anyone need to see any of those done out or have any questions? All right, go ahead and take a break then for 10 minutes. Come back at 2:20, okay? I'll pause the recording. We will be back. Everybody, I'm back. So a little bit more advanced. Is that the right word? Challenging? More advanced ones. Still from section 3.1. But these are going to force us to do more than 2 steps. Maybe combine like terms. Maybe get rid of a parentheses. Move stuff around. So I'll just talk through a few, I think. Here's one that's one of my favorites. And remember, whenever you see these two, just that variable stands for a number, just some number. So it means 3 times a number minus 2 equals 2 times that same number. A lot of people, when they're first learning algebra, can just do that in their head. They just know the answer right away. The answer's 2, and they'll be like, oh, obviously it's 2. But some people are like, I have no idea. I have to do the steps. That's okay, either way. So we have this situation, like if we have variables on both sides, that's the first step of the trickier ones. Tomorrow we'll talk about equations that have no solution. Sometimes that happens. Sometimes they have infinite solutions. Sometimes they have all kinds of action, like this one we'll have to do on the next page. But these are still linear equations, they're called. Linear equations. Because they tell the story of a line. If you graphed them, which we'll do in chapter 4, they would make a line or 2 lines. So like we're looking at where do the 2 lines cross right now, actually. But we don't have to graph them right now, but that's why they're called that, linear equations. So they still have just a single variable, not to a power, and then some other numbers floating around and symbols and stuff like that. So that's why they're called that. And then in the next levels of algebra, you do more different equations, like, anyway, I don't need to go on like that. But our goal, when we look at this, we think of kind of a strategy. We need to combine like terms to simplify. And so those that I just pointed at are like terms because they both have a y to the power of 1. That's not showing, but it's the power of 1 there. They both have a y to the power of 1, so they can combine. This one can't jump in with them exactly, so it's going to have to stay separate, but we still know how to deal with it. So we'll just combine like terms, and 2y over here is, oh, actually, you could move 2y over there, take away 2y from both sides, and end up with the answer. Or you could move 3y over here. So start trusting your judgment. The more you practice, the more you'll have really good judgment too about these, because you want to do it the most efficient way possible for yourself. Like you don't want to make it any more work than it has to be. I usually move things around so my variable will be positive, and so I won't make a little sign mistake. That's me personally. So I normally would take away 2y from both sides. And then 3 minus 2 right here is 1y minus 2 equals 0. 2y minus 2y equals 0. So I'll put it over here so you could see it better. And then 1y is just y, but we could add 2 to both sides. And y equals 2. Then we can check, but I'm not going to check all these. Like I was saying before, we don't have to check them all the time. Just once in a while, just check in and make sure you remember how to check your answers. That one sometimes throws people off because of this weirdness over here. But 0 is it's a real number. It counts as a real number. It also holds a place. So it's not wrong to put it that way. So if you had done it the other way that I mentioned, you still should get the same answer. You'd end up with negative y equals -2. Then you'd have to really divide both sides by -1. Does anyone have a question about that one, number 1? So this one, along the same lines, I would move 5t, whoops, not 15. I would move 5t over to the right. So if I add it to both sides, this will 0 out. And that will be 6t plus 16 equals 4. I'm going to go to the next page so that one can fill up the whole page. So I'm modeling. I need to model the good way to do these step by step. But people who've been sending me their work, looks really good last week. So I added 5t. It would have worked the other way around too, though. So start, as long as you do the same thing to both sides. So like I said, start trusting yourself, like make sure it's working for you. Now we want the variable on one side by itself eventually. So we'll get 16 away from it next. And then it'll 0 out. And now it's saying 6 times what number equals -12. Divide by exactly what's with t. So t equals -2. So that's that one. That was number 2. Look that over and let me know if you have a question about that. Or if you're shy to ask in front of people too, just ask me privately or send me a chat or we can have a meeting. Anything like that is fine. Because sometimes there'll be people who learn to do their equations differently, but they're still getting the answer the same. And they worry sometimes that I'm going to give them zeros because they're not doing it my way. No, I'm excited to see new ways. But just remember, you can ask anytime. And then I jumped in and threw a harder one in there just so we'd have a little variety, and then we'll practice some more. Well, I'll do another example or two. There, 12 minus w equals -2 times the quantity of 3w minus 1. So this time, our first step is to remove symbols of grouping. So I'll just write it like that way. We can't really do it with the parentheses on there. There are some tricks where you can, but it's a little bit sketchy. So we'll just do it the proper way. Distribute through. And watch your signs. So whenever you see parentheses, you want to get that gone before you start moving things across the equal sign and stuff, like playing fast and loose. Because remember, inside the parentheses in here, that's like in lockdown, like it's locked up. It's in jail. But we have the key. That's the key. The distributing, we get it freed up, break it out. So then we've got this. And I'm double checking my signs. All right, now I want to get the W's together, combine like terms. I would add 6W to both sides. Because like I said, my personal MO is I like to have my W be a positive number. -1 plus 6 is +5. That zeroes out. 2 is on the right. I often know people and have students or friends who do several steps at once, who do these in their head. I'm proud of you if you can do that. That is great. They'll probably get harder enough that you'll need to write them down at some point, but maybe not. So if you are doing them in your head, I'll ask you, like, where's your work? Sometimes I'll ask people to talk me through it, what they did, what their logic was, if they're doing it in their head. That way I can make sure their process is okay, you know. But don't worry about showing all your steps with me either. Just make sure what steps you do show nice and neat. And I line them up like that. 2 minus 12 is -10. So this one is one of my faves because we have to combine like terms, get the W's together, get the constants together. That's what's happening right here. Then there's some negative signs. Then there was distributing. So this problem has a lot of good, delicious stuff. Take your multiplicative inverse to both sides. So W is going to be -10 divided by 5. -2. Again, weird that that must be my number, huh? If I was a gambler, that's the number I would pick today, huh? -2 keeps coming up. So look that over. Does anyone have a question about that one? That is one of the more tricky ones in section 3.1. Okay, let's practice a few like this that have more than 2 steps. Practice 4. 1, 2, 3. After this, we'll do a couple geometry problems, a story problem, and then we'll stop. We'll stop by 3 o'clock at the latest and let you have time to work on your assignment. The assignment is the chapter 2, part A assignment. I'm going to put some extra credit worksheets up on Moodle in case somebody wants to do more practice, and they can send them to me, scan and send them to me for extra credit. And also I forgot to announce that I updated all your grades. My grade book, I use the Jenzabar grade book. In Jenzabar, where your attendance is, where your registration is and stuff, your transcript check and all those things. So in Jenzabar grade book, you should see your grade all caught up as of now. If I made a mistake though, just let me know. I'm not beyond mistakes. I think everybody's going to make mistakes sometimes, right? I mean, I don't want to. Okay, let's do A over 6 plus 1 equals 4. Didn't do one like that for all of you, but we'll see how you do with that one. Then back to that page that I was looking at. Here we go. 24 minus 5x equals x. 4x minus 2 equals 3x plus 1. There, and that one. 3 times the quantity y plus 1 equals -y minus 9. There, that's hard enough for today, huh? So we'll pause, like I said, I'll pause it again for a few minutes. Send me answers, or I don't think I'll put people on the spot and call on you for these, because some people get a little anxious about when they get harder. But you can call them out if you want, but not yet. Just let's give it 2 minutes. Okay, so the steps for these ones, subtract 1 from both sides. Remember, that's that additive inverse. So a over 6 plus 0 equals 4 minus 1. Then multiply both sides by that's the multiplicative inverse or the reciprocal. Or you can undo division by multiplying. That's another way to look at it on both sides. That'll cancel out to 1. So you end up with a over 1 equals 18 over 1. So a equals 18 for the first one. Does anyone have a question about that first one? The way I did that work is hard to follow. Like if I do my equations that way, I come back to them later. It's not very proper. It's just hard to follow. So a equals 18. I should have used more space. And we can check it by looking here. 18 divided by 6 is 3. Add 1 equals 4. So it checks out. The next one, we want our x terms to get together. So add 5x to both sides. And like I said before, I like to have a positive coefficient with my x term. But you don't have to. Sometimes people want their x term to be on the left, like beyond all reason. They just want it on the left because that's how they learned it. That's okay. It will still work. Divide by what's with x. So x is going to equal 24 divided by 6. It's 4. Any questions about that one? Number 3, we already did a few like that. We want the x terms together. So I'm moving the 3x. So we're going to end up with a positive 1x minus 2. That zeroes out. And then add 2 to both sides. So that 1x is the same as x equals 3. And we can talk through the check sometimes, like I was saying. I'm kind of repetitive when I'm teaching this. I apologize for that. But 4 times 3, take away 2, that's going to be 10 on the left. That if I plug in 3 right here, then I'll have 10 on the left. If I plug in 3 on this side, I'll have 9 plus 1, which is 10 on the right. And that would check. So I could talk through the check sometimes, or if I was explaining it to someone. There's a lot of different ways to explain that. Any question about that one, anybody? On your assignment, you have several tries for each problem in case you have issues with the positive and negative signs and things like that. Some of the operations that you have to do, adding integers and things like that, that just take a little practice. It's no big deal. And the worksheet, the extra credit worksheet, you can show your work for each problem, so you get your credit. Distribute first to remove your parentheses. Now let's get our y's together. So I'm going to add y over here and subtract 3 from both sides. Some people do it this way. Sedna teaches it that way with those arrows. So just wanted to show that so you know that's legit for sure. But divide both sides by 4. So that last one is -3. I made that one up just now. And so I had to definitely do the check because I didn't have the book answer anywhere or any answer key. So I did the check to that on my paper. Oh, well, I'll show it to you. Let's see if I can. Yeah. I can. There's the whew, that was a headache. Now I felt bad because that was a harder one. But that was the steps. And then the check I showed down below and then put a check there. So that's what I'm looking for on when people show their work. Kind of like number 4. And most of you who have sent me work are already doing that, which is so sweet and great. Alrighty, 2 story problems, and then we're moving on up, moving out. This is in the textbook, page 105, number 52, and then we'll do page 106, number 55. And while we're doing that, I'll talk the talk of the story problems also. So they say geometry right in front of this problem, which scares people sometimes, the word. Geometry just means measuring the earth, the globe, the earth. So earth measure. So this one says the language I wanted to show you. The length of a tennis court. I'll just write court. Is 6 feet more than the width. Oh, then twice the width. There's more, but when you see that kind of language, we know it's a tennis court, a rectangle. We know there's length and width. And they told us that the length is 6 feet more than twice the width. So we translate it to our algebra symbols. And I've said that before, and I'll always keep saying algebra is just another language. It springs from the mathematics language that you already know. It's just a language to learn how to write it down. So we want to simplify it as much as possible and not have all this wordiness. And we want to just like stick to the math. You know, what was that show when they'd say stick to the facts? We just want to stick to the facts and just not clutter it up. And then the last thing it says for this story problem is find the width of the court when the length is 78. So find the width. You can find other things too. Find the width of the court when the length is 78 feet. So we got to read them carefully. Sometimes read it out loud. Sometimes repeat it. Draw a picture. You can make your picture fantastic if you want to put the whole lines but that might distract you too. So you don't have to. You could put the people in there even. And we can find the perimeter if we wanted. We could find the area. But they told us one more thing, that the length is 78 feet. So find the width when the length is 78. Well, we can, in this one, then we figure out what we need to find, read it through a couple times, make a picture, like I said, make sure we've got more than is plus, twice is 2 times, those key words that are so important. And then we're going to set it up carefully in an equation. So if the length is 78, we should be able to say, okay, 78 equals 6 plus 2 W. That's our setup. That's the hardest part, translating it and setting it up. Then in the story problems, the algebra itself isn't usually hard, but it's that language setup, reading. Sometimes if we've had students who come to OLC with a third grade reading level, and that's okay. We can take them wherever they're at, teach them and get them through college for sure if they're ready to work, right? But and story problems throw them off though, because their reading level might not be that strong at first. So we always like, talk to me if you have trouble with these, or I'll tell you more strategies as we go along. But never let them stop you, because in real life, that's when math is useful. The real life situations, like that's when it's really valuable. Like it helps us get through life if we know how to apply it to our real life situations. But sometimes people are just like, oh, keep me away from those story problems, and I just want to do a worksheet, which is fine. I'll give you worksheets too. But just remember, it's a good skill and process. Good strengthens our brain. So let's take away 6 from both sides to get our constants together. 2w equals 72. And remember, that's 2 times w. So divide both sides by 2. And I didn't even talk about guesstimating. I'll say that in a second. And I forgot my label. So this would be feet. And then we always change it back to words. The width is 36 feet for this court. So the estimating, remember when we're estimating, draw that picture. The length is the long side. The width is going to be shorter than that, probably a little less than half of that. So the width is going to be shorter than the length. So we can guesstimate before we even do that algebra, like before that happened, we could just kind of guess like, I would have guessed like 35, maybe 30. And also from playing tennis or being at a court, if you've seen one. Anyway, that's the answer to that one. Does anyone have a question about that one? Hold on, I'm gonna look at my. I'll show another one that I wasn't planning on. Don't worry, it's not going to be that big of a deal. This one was number 51, and it says a yield sign is a triangle with all sides equal. So they show the picture like this in the book, and then they say the perimeter of this sign, I wanted to explain that word, is 225 centimeters. Find the length of a side. Find x. So this is another example. The perimeter is the distance all the way around. So if the distance all the way around is 225, that's all these x's added together. X plus x plus x. And so that would be the setup. That's using perimeter. This with its label. That's called this, I call it the setup. Kind of like in Ocean's 11, I always think about it that way. Like that, with those Ocean's movies, like the whole thing is, almost the whole thing is the setup. Like, I love that because it reminds me of these math problems. Sometimes that's the biggest part of the battle is the setup. If you really carefully do that, then everything will go off without a hitch. You'll end up on an exotic island. No, but anyway, but let's say now I want to guesstimate before I do any math. Just think, well, if 3 of them is 225, what's just 1 gonna be? So I'd be like, I don't know, maybe around 70, 70, 70, and 70. That would make 210. So it's going to be close to 70. So I would guesstimate. So I'll put question mark here. You don't have to do that, but I would be like 70 centimeters equals X, just guessing without even trying to think math wise. So it's good to do that because it helps our brain kind of check in like, is this making sense? Like, yeah, Valerie, you got it. Yep, so if I do all the steps, I'll have 3x. Remember, it's not x to the third because they're being added. 3x is, oh geez, my 225 centimeters. And then do my algebra, divide both sides by 3. Keep the centimeters on it. And x equals 75 centimeter. And then we write the answer just a lot like if you have taken Lakota Language 1. If they ask you a question, you use the words of the question for your answer, you know, like how old are you? Or yeah, what age are you? It would be, wouldn't it? What age are you? I am this age, you know, like that. Where are you going? I am going here. Like we do that when we're answering. So the answer would be one side of this sign is 75 centimeters long. So we can use the question to do the answer and not overthink it, not make it too fancy or complicated or anything. Anybody have a question about that? I see it is 3 o'clock. So I'll skip the fancier problem I was going to do. That's enough for now. That combines some little bit of geometry with algebra, and that's problem solving, the language, like we had in this one, 6 feet more than twice, like that kind of language. It's sometimes a kind of a it's kind of a push just to get it into algebra, but we'll keep practicing lots more tomorrow. Tomorrow's a quiz. After we'll go over any questions anyone has. I'll review once more what we did today, briefly, and then we'll have the quiz, which will be a handout that you can just either write it in your notebook or print it off and write on it. So it'll be in Moodle. I'll open it right at class time tomorrow. Well, right after I go over the questions anyone has. So we'll have a quiz tomorrow, and then we'll go into a little bit more equations and problem solving and stuff like that tomorrow. More practice. So a lot like today, but with a quiz. Any questions, anybody? Concerns? News about weather? Did anybody get more bad storms during this class time?